So the last part of the exception handling series of discussions will focus on an example that will show how to apply all these different methods to a fairly straightforward but fun example use case. So you can find this use case, as always, in my EX8 project in the Java 8 folder in my Live Lessons GitHub repository. This particular example is going to asynchronously create a big fraction that will have a numerator of 100 and a denominator that will be set programmatically, which can either be 0 or non-zero. As you might expect, if the denominator's value is set to 0, we're going to get an arithmetic exception because you can't have 0 as the denominator. The thing to remember is that unhandled exceptions will terminate programs. If you have a thread that's running, and it doesn't matter which thread it is, it could be a background thread, it could be the user interface thread, it could be a main thread, whatever. If an unhandled exception occurs that's not handled by anything, that will cause the program to terminate. And we don't want that. So let's take a look at what happens here. So here we have supply async, which may or may not cause an exception. We put the handle exception handling method here, and this will handle the outcome of the previous stage. It's always called regardless of whether an exception is thrown or not. So the way we find out if an exception is thrown is there's basically I think it's a by consumer here, where it'll give us the fraction, or maybe it's a function. We take the fraction and the exception. These values are mutually exclusive. Only one is ever set at a given time. If the fraction is null, that means an exception occurred, or conversely, if EX was non-null, that means an exception occurred, in which case we're going to return a 0, the big fraction constant 0, which will swallow or hide the exception. So we're doing error handling. And I asked ChatGPT to generate me an image visualizing exception hiding, and this is what it came up with, which I thought was pretty clever. So you can see that it's got a catch block in here, and if something goes wrong, we were kind of hiding the fact. It's like the Wizard of Oz or something like that. So that'll swallow the exception. If there is no exception, it'll multiply the big fraction by some constant. And then the thing to note here is that handle will always return a value, and therefore can change the return value. And it also swallows the exception. In this case, we're just going to print the result as a mixed fraction. And of course, if it changed it to a 0, we're going to get a 0 printed out. Whether that's what you want or not is a whole other story, but that's how it works. Let's take a look here using the exceptionally method instead of using handle. So exceptionally is similar, but it only handles exceptions, as you might expect from the name. Once again, we make ourselves a big fraction that will either throw an arithmetic exception or not. If all goes well, we will multiply that big fraction by some constant. That's the case where the denominator is not 0. However, if an exception is thrown, this call will be skipped, and instead the control will transfer here to exceptionally. That handles the case where the denominator was 0, and therefore an exception was thrown. Otherwise, this call is skipped. So either that call will run or this call will run, but not both. You can think of exceptionally as similar to catch in a Java try-catch block. In other words, control will transfer to it when an exception occurs. And once again, in this case, we're going to swallow the exception, and we're going to hide it and return 0, which will then be printed out. If for some odd reason your exception handling is going to take a very long time to run, you can run things in the background. Obviously, returning the constant 0 will not take very long to run, so that would be overkill. And then we, again, display the result as a mixed fraction. The third and final thing we're going to look at here is really just to show how this works. This is not actually a useful solution, as we'll see. In this case, we're going to call supply async, which may or may not throw an exception. Then apply will be called if there's no exception. And whenComplete will always be called, whether an exception occurs or not. Much like handle, whenComplete is passed in 2 parameters to be the fraction if it's all as well and the EX if it's not. So I think that's, again, it's a by consumer. These values are mutually exclusive. Only one is ever non-null at a time. In this case, if fraction is non-null, we print the mixed string. Otherwise, we print out the exception message, because every exception should have a message that says what happened when went wrong. So you can basically think of whenComplete as essentially like peek in streams. It's just a way to log or note what happened. So it has a side effect. It does not change the return value, and it does not swallow the exception. So if we were to do this code and an exception were to be thrown, we would print out the exception, but the program would still exit because we haven't caught anything. So again, whenComplete is really just there to kind of give you information about debugging. So that's the end of the second part of this discussion. And now you should have a pretty good idea of how to handle exceptions with Java completable futures.